Section 1.2, use segments and congruents. So our goal is to be able to use segment postulates to identify congruent segments. First thing we need to discuss is distance. A couple things to note about distance. It is always positive. And we say it is the length between two endpoints. That means we can find the length of, or the distance or length of a segment, but not a ray, not a line. So one of the things is using a ruler, the tool we use for measuring a segment. So we have this segment, for example. And if we are measuring it, we want to line up with the 0 right there. We want to measure with 0. Now, to note when doing this, there are two systems, what we call the imperial or the standard system with inches. If we were to measure this to the nearest inch, this would be 2 inches. If this were to the nearest half inch, it would be 2.5. If we're looking at the 1/4 inch, it would be 2, 2.25, 2.5. It would still be closer to 2.5 than it would to 2.25. So we'd still say it is 2.5, even though we're rounding to the nearest 1/4 of an inch. Now, if we're measuring to the nearest eighth, I would say it's closest to 2, 1/8, 2/8, 3/8. So we'd say it's 2 3/8. If we switch to the metric system, we can round to the nearest centimeter, in which this case it would be 6, or we could round to the nearest millimeter, in which there would be 61. Remembering that each centimeter is 10 millimeters, so 6 would be 60, and I would say this is about 1 past, so this would be about 61 millimeters. A term we're going to use is the term between. A definition we're going to use for between is a collinear, again meaning on the same line. It's a collinear point on a segment with given endpoints. So for example, C here is not on the line. So we say it is not collinear, and thus not between. Where here, E is on segment DF, so we will say that E is between D and F. And that's all that between means. It's on the segment. Our segment addition postulate, this is pretty straightforward to use. It reads that if B is between A and C, then AB plus BC equals AC. What this looks like. If I have a segment and I add another segment to it, as long as you have the same point. So what can happen is I can move these points together to where B is the same point. If I were to put these directly on top of each other, and then of course one hides a little bit, we get the overall segment. So what we do is we say that we have these two segments added together equals the full segment. And you've done things like this already. So a nice easy problem like this is to find OQ. So an example of how you could set this up would be to say that OQ plus QP equals OP. We do not know the length of OQ, so we will say OQ plus 17 equals, and then OP is 42. Subtract our 17, and we get that OQ equals 25. We do not have any units in the problem, so we do not have any units on our solution. It's just that OQ equals 25. Congruent segments. First we start with the symbol for congruent is an equal sign with one squiggly line above the equals. That is a symbol for congruent. If segments are congruent, they have the same length. So they're both 3 inches, or they're both 5 inches, or 14 millimeters, or whatever unit they're measured in, they're the same length. If they're different, they're not what we call congruent. And our last example, what I'm going to ask you to do is to graph these points and determine are x, y, and wz congruent. So I plotted x and y because it's asking x, y. And since it's a vertical line, I can simply count, and it is 8 units. And now I'm going to do the same thing with WZ. So I'm going to go plot W, and then I'm going to plot Z. Draw that segment, and I'm also going to count 2, 4, 6, 8. So WZ, also 8 units. Since they're both 8, yes, the segments are congruent. If they were different lengths, we'd say they're not congruent.